Now, to get us warmed up before we really jump in, here are some radicals for you to go over and simplify. I want you to just pause the video, go through, figure them out. And also with these two that have the fractions, remember you can split radicals. So we can think of this one on the left as the square root of 1 over the square root of 81, and then simplify it. So pause the video, give them a try, come back and check your answers. Now looking at our answers going across in rows, we have 3, 2, 5. Second row, 4, 3, 2. In the third row, the square root of 1 over 81 is just 1/9. Then we have 2. And then notice with this last problem, when we take the cubed root of 8 and 216, you get 2 6. However, we can always simplify. And so if we simplify, we end up with our final answer of 1/3. Also, what's going to be helpful is a fraction review. So I want you to pause the video once again, go through and solve these problems. Remember, with adding fractions, we need common denominators. With multiplying fractions, you just multiply straight across. If you have an answer that can be reduced, you need to reduce it. So pause the video, come back, check your answers. So looking at our answers, we get 11/12. The second one initially gives us 20 over 15, but we can reduce to get 4/3. The third one is 8 over 21. And the final one gave us 2/10 initially, but we can reduce and get 1/5. Notice, if it is an improper fraction, leave it as it is. Don't switch things to mixed numbers. It's just not necessary. So, jumping into the new stuff today, we have to rewrite each problem in exponential form. So we're going to make it into an exponent problem, and we have to solve. So, rewriting the square root of 25. Remember, we're going to have 25. The power is 1. The index is 2. So we would rewrite it as 25 to the 1/2, which we should all know is just 5. The cubed root of 27, we may know that it's 3, but if we rewrite it in exponential form, it'd be 27. The power is 1, the index is 3. 27 to the 1/3. And last but not least, the square root of 4 cubed. Our base is 4, our power is 3, our index is 2. So we have 4 to the 3/2. And if we solve this, 4 cubed is 64. And then the square root of 64 is 8. Switching it up, we now need to rewrite it in radical form and then solve. So here, notice that 1/2 is only on our x. So 25 is going to be outside. We have a radical. Inside goes an x. The power is 1. We're not going to write it. Index is 2. Don't need to write it. It is simply 25 times the square root of x. Next problem, everything is raised to the 1/2. So everything is going to go inside our radical. We have a 25x. The power on all of this is 1, so we don't need to write it. Index is 2, don't need to write it. However, if we were going to solve this, we can take the square root of 25 to give us 5. And then we still have the square root of x. So our final answer, 5 times the square root of x. And last but not least, we have a over 9 to the 2/3. Rewrite it in radical form. So we have our radical. We have a over 9. The exponent on this is 2. Our index is 3. Now when we solve, I'm going to have the cubed root of a squared over 9 squared, which is the cubed root of a squared over 81. Then we have to ask ourselves, can we take the square root of 81, or the cubed root of 81? And we can't quite take the cubed root of 81. It doesn't work out to be perfect. And so for today, we're going to leave it just like this. 3, the cubed root of a squared over 81. Here, the directions say simplify using properties of exponents, then write it in radical form for your final answer. So, properties of exponents. Well, this is all just multiplication going on. So, I'm going to multiply my numbers, add the exponents on my axis. So, 8 times 3 gives me 24. And then I have to add my exponents. So, I have to think off on the side. What is 2 plus 1/3? Here is where those common denominators are going to help. So 6/3 plus 1/3. Oh, my exponent is going to be 7/3. Moving forward, I need to rewrite this in radical form. So I have 24, and I have the cubed root, because my index is 3, of x to the 7. And there is my final answer. The next problem, we're first going to have to distribute these exponents, and then think about things. I have 36 to the 1/2, x to the 1/2, 49 to the 1/2, and another x to the 1/2. When I look at this, personally, I know 1/2 is really just the square root, because that's what we've been talking about. So the square root of 36 is just 6, x to the 1/2. Square root of 49 is just 7, x to the 1/2. And then it's just like the last problem. Multiply our numbers, add up our exponents. I get 42 times x to the first power. We don't need to put this in a radical because there is no fractional exponent. So our final answer is 42x. And last but not least, 2 more to try. It says simplifying using our properties, write it in radical form. So here in this first one, we're going to have to distribute that 1/2. So we get c to the 1/2, d to the 1/2, and then we have a d to the 1/3. From there, like things, we have 2 d's. We can add up those exponents. 1/2 plus 1/3 is 3/6 plus 2/6. So our exponent is really going to be 5/6. So we have c to the 1/2 and d to the 5/6. Now we need to write it in radical form. So c to the 1/2 is the square root of c. D to the 5/6 is going to be the 6th root of d to the 5th. And there we go. And last but not least, x to the 2/3 stays. We're going to distribute this 1/3 power to those items. So we have x to the 2/3 times 8 to the 1/3 times x to the 1/3. Well, 8 to the 1/3 is the cubed root of 8, which is 2. And if I add my exponents, 2/3 plus 1/3 gets me 3/3, which is just 1. So this is going to become 2 times x. No need to put it in radical form because I have no fraction x.